Okay, so for this one, section 14.4, practice problem 14.8, the build problem, it says to use the graph to determine the value of K, that's the rate constant, at a temperature of 475 Kelvin, right? 475 K, K is the abbreviation for Kelvin, so that's telling us the temperature. Now, in order to solve this problem, what you do is take a look at what the graph shows. This is an Arrhenius plot. It says the natural log of the rate constant K. So that's lowercase k is the rate constant. Uppercase K is the Kelvin temperature. We're plotting that versus 1 divided by the temperature, which is expressed in reciprocal Kelvin, or 1 over Kelvin. Okay? So to figure this out, we don't have the temperature plotted on this graph. We have 1 divided by the temperature. So the first thing to do is to say if the temperature is 475 Kelvin, then what would be 1 divided by the temperature so that we can look on that graph and figure out where it shows up on the x-axis, because 1 over temperature is on the x-axis. So let's just do 1 over 475 Kelvin. And notice that the numbers in there are in decimal notation. They're not doing it in scientific notation. So if you take 1 divided by 475, you get 0.0021. So that's 0.00. In fact, let's go one more digit there. 2105. So I guess we could round that to a 1. And then that would be reciprocal Kelvin, right? 1 over Kelvin. So now what we do is we look on that graph. So I can't easily edit the graph because it's a picture. But let me show you what I mean by that. What you want to do is you want to look on the x-axis where that number is. So, 0.00, sorry, let me erase this. So 0.00211. So if you look over there, you can actually see on that plot, there's actually a point on the x-axis that's pretty close to that. It's 0.002. That's pretty close. But then if you look, there's 0.00205, and then there's 0.0021, and then there it's pretty much where it ends. So it looks like looking at that x-axis is pretty much right where it ends, where the red line ends. It's right there. And so what you do then is, let me make this a little more accurate. I'm going to erase this part here. Because if you look at it, just the graph pretty much stops a little bit after the 0.0211. And so what you do is you read across. You read across horizontally to the y-axis, and you see where that is. Now, looking this, I'm eyeballing it here. You can't be real precise on this. There would be some ways you could be more precise by figuring out a slope and a y-intercept. You could go through that method. I'm not going to go through all of that. But if we come across, it looks like it's intersecting at about negative 2.7, because it's negative 3 here, and it's negative 2.5 here. So it looks like it's somewhere around negative 2.7. Now, that negative 2.7 is equal to the natural log of the rate constant, ln of k. That's what we're plotting on the y-axis, is ln of k. So that's ln of k. If we want to find out what k is, we use the inverse of the natural log, the antilog. And the antilog of natural log is called e to the x. So what we would do is we would say e to the x, in this particular example, would be e to the ln of k. And remember, when you do the antilog of the natural log, you're doing natural log and then anti-natural log, that just gives you the variable that you're looking for. So that'll give you k. Essentially, this is not proper mathematical terminology, but essentially the e undoes what the ln does. So if you do both of them, you just get what's up in the exponent, which is the k. So now you have, whatever you do on the right side, that was the right side of the equation, you also have to do on the left side. So that would be equal to e to the minus 2.7. Now, there are courses where you might be asked to be able to approximate that calculation in your head, but we're not going to do that in here. So this would essentially be equal to this, you could do this on your calculator, but the negative is another way of saying it's just 1 over e to the 2.7. Now, e is a little bit under 3. It's like 2.78. So really, it's sort of like 3 to the third power, which is 27. So this would be 1 over 27 or 1 over 24 or something like that. So it's going to be a number that's less than 1. So e to the 2.7, of course, you want to be able to do that on your calculator. So it's the anti-log of minus 2.7, and that is 0.067. And that would be the value of the rate constant. I wouldn't worry about units here, but we should get something that's close to that. So if the actual answer in the textbook is a little bit different, then that's fine. We're pretty close to there. You can tell just by looking at that graph, just eyeballing it, that it's going to be somewhere between negative 2.5 and negative 3. So it's going to be around that number there. So hopefully that helps you out for this particular problem.